Hello friends, you are watching YouTube channel Number Collage dedicated to mathematics. In this video, we will discuss in detail JEE MAIN Mathematics paper which took place in morning shift on 24th January 2025. It is given that C bar is coplanar with A bar and B bar. So we write C bar as a linear combination of A bar and B bar where x and y are scalars. Writing A bar and B bar. This can be written as A bar dot C bar is 5. Writing A bar and this C bar taking dot product. After simplification, 14x plus 2y equals 5. We name this 1. C bar is perpendicular to B bar, which implies C bar dot B bar is 0. Writing this C bar and this B bar taking dot product. After simplification, it is 2x plus 11y equals 0. We name this 2. Solving this equation 1 and this 2 simultaneously, we get x equals 11 upon 30 and y minus 2 upon 30. Putting these values of x and y, we will get C bar equals 1 upon 6 I cap plus 2 upon 3 j cap plus 7 upon 6 k cap. Magnitude of C bar square root of 1 upon 6 square plus 2 upon 3 square plus 7 upon 6 square. After simplification, mod C bar is square root 11 upon 6. Hence, the correct answer option is 4, square root of 11 upon 6. This is a special function known as beta function, and we have to find the value of this part. Let's not go deep in beta function and make it simple. We write the required quantity as by substituting 9 and 10 in place of m and 14 and 13 in place of n here. So this becomes, since limits of integration are same, we can combine these two integrals and write taking x raised to 8 common and 1 minus x raised to 12 common, 1 minus x plus x dx, which becomes, now carefully observe this integral here where this m is obtained by adding 1 to this m minus 1 and this n is obtained by adding 1 to this n minus 1. We will do same thing here and write I 8 plus 1 comma 12 plus 1, thus getting I 9 comma 13. So the correct answer option we get is 4, I 9 comma 13. In this question, we have to find alpha plus 2 beta. This limit is given to be beta and there is alpha also here. Here there is f of x and in the given data there is f of 1 upon x. So we have to eliminate this f of 1 upon x and get this data purely in f of x. First we write the given thing and name this 1. Next we replace x by 1 upon x. So this 1 becomes, we name this 2. Now in order to eliminate this f of 1 upon x, we will multiply this second equation by 6. So it becomes 6 into minus 6 f of x becomes minus 36 f of x plus 6 f of 1 upon x equals 70x minus 15. We name this 3. Now we will add equation 1 and equation 3. That gives minus 35 f of x equals, that gives, further it gives 35 into bracket, which finally gives f of x equals minus 2x minus 1 upon 3x plus 1 upon 2. This limit is given to be beta, so we write beta equals this limit, substituting f of x in order to get a finite limit, this 1 upon alpha x and minus 1 upon 3x must vanish. That suggests us this alpha equals 3. So we get alpha equals 3, and when we solve this limit as x tends to 0, we get beta equals 1 upon 2. So the required value alpha plus 2 beta will become 3 plus 2 times half 4. Hence the correct answer option here is 3, 4. In this question, we have to find absolute difference between 20th and 15th terms. First, we will find Sn in terms of n. This we write as 1 minus half plus half minus 1/3 plus etc. plus so on and so forth. From this 1 half 1/3 we write 1 upon n, then minus from this half 1/3 1/4 we write 1 upon n plus 1. Here minus half plus half 0, minus 1/3 plus 1/3 0, etc. 1 upon n minus 1 upon n. So this 1 will remain, minus 1 upon n plus 1. So Sn will be n upon n plus 1. Next, sum of first 6 terms of an AP with first term minus p and common difference p is S6 equals 6 upon 2 into 2a 2 into minus p plus n minus 1 6 minus 1 into d, that is 5p, that gives S6 equals 9p. But this S6 is given to be square root 2026 S2025. So this equals square root 2026 S2025. Now from this relation, S2025 will be 2025 upon 2026. So 9p will be square root 2026 into 2025 upon 2026, which equals square root of 2025 45. That gives p equals 5. Now the absolute difference between 20th and 15th term, T20 minus 215, will be a plus 20 minus 1 19d minus a plus 15 minus 1 14d mod of 5d, but d is p mod 5p and p is 5 25. So the answer option here is 125. In this question, we have to find limit as x tends to 0 of this function. This limit is of the type 0 upon 0. So first we will rationalize this part of the function and write limit as x tends to 0 1 upon sin x. We will use s for sin x into, in the numerator, 2 cos square x minus cos square x cos square x. We will use c for cos x plus 3c minus s minus 4 upon square root 2c square plus 3c plus square root c square plus s plus 4. Limit as x tends to 0. This cos square x equals 1. This cos x equals 1. This cos square x equals 1. This sin x equals 0. And the denominator becomes root 5 plus root 5, that is 2 root 5. So we write in the denominator root 5 plus root 5 will be 2 root 5. This we write 1 upon 2 root 5 limit as x tends to 0 of cos square x plus 3 cos x minus sin x minus 4 upon sin x, which equals 1 upon 2 root 5 into limit as x tends to 0. Here we will use L'Hopital's rule to evaluate this limit. So we write derivatives of numerator and denominator separately. Minus 2 cos x sin x minus 3 sin x minus cos x upon cos x. 1 upon 2 root 5 as x tends to 0. Sin 0 will be 0. This sin 0 will be 0. This cos 0 will be 1. And this cos 0 1. So this will be minus 1 upon 1. And the value of the limit minus 1 upon 2 root 5. Hence, the correct answer option is 4. Minus 1 upon 2 root 5. In this question, we have to find area of triangle ABC. Points A and C lie on the line. Side AC is 6. For finding the area of the triangle, we have to find height of the triangle PD, and base AC is given to be 6. Coordinates of B are 1, 2 and 3. Let each ratio in the equation of line equals lambda. So the coordinates of point D will be of the type 3 lambda plus 6, 2 lambda plus 7, minus 2 lambda plus 7. DRs of BD will be 3 lambda plus 5, 2 lambda plus 5, minus 2 lambda plus 4. Since BD is perpendicular AC, product of DRs of BD and DRs of AC 3, 2 and minus 2 is 0. So we write, solving this we get lambda equals minus 1. Now we write coordinates of point D 3, 5, 9. By distance formula, length BD will be square root of 49, 7. Now area of triangle ABC is half base into height 21. Hence the correct answer option is 2, 21. This question is on probability, and we have to find the probability that A wins if A makes the first throw. Under certain conditions which are given in the problem, it is given that A wins if he throws a sum of 5. That means if he throws 1 4, 4 1, 2 3 or 3 2, which is 4. So n is 4 here, and therefore probability of A's success is 4 upon 36 because pair of dice is thrown. That will be 1 upon 9. From this we can find probability that A fails will be 1 minus 1 upon 9, 8 upon 9. It is given that B throws a sum of 8, that is when he throws 2 6 6 2, 5 3, 3 5 and 4 4, which amounts to n equals 5. So probability of B's success will be 5 upon 36, and probability of B's failure will be 1 minus 5 upon 36, 31 upon 36. Please note that A starts the game and A must win. So the probability of wins will be, in the first attempt A wins, there is no question of B winning. In the second case, probability that A fails, probability of B fails into probability of A wins, plus in the third case A fails, B also fails, again A fails, B fails, and finally A wins, plus so and so forth. This will continue. Putting the values, 1 upon 9 plus 8 upon 9 into 31 upon 36 into 1 upon 9 plus 8 upon 9 into 31 upon 36 into again 8 upon 9 into 31 upon 36 into 1 upon 9 plus so and so forth. This is an infinite GP whose first term A is 1 upon 9 and common ratio R is this 8 upon 9 into 31 upon 36. So the probability that A wins the game is sum of all probabilities A upon 1 minus R, which is 1 upon 9 upon 1 minus 8 upon 9 into 31 upon 36, 1 upon 9 upon 1 minus 62 upon 81. Let's write remaining calculations here. 1 upon 9 into 81 upon 81 minus 62, 19. So the probability that A wins if he makes the first throw will be 9 upon 19. Hence, the correct answer option is 2, 9 upon 19. In this question, we have to find area of the region bounded by the parabola x square plus 4x plus 2 and the modulus function x plus 2. Let us draw combined graph of the parabola and the modulus function. This would look somewhat like this. Equation of parabola is y equals, that we write. From this we get vertex of parabola as minus 2 comma minus 2. Next, by putting x equals 0, we get y equals 2. So this point will be 0 comma 2. We have modulus function y equals mod x plus 2. When y is 0, x is minus 2, which is this vertex minus 2 0. Solving parabola and modulus function simultaneously, we get this point minus 4, 2. We can draw a rectangle here, this one. If we observe combined region of the two functions of which we have to find the area, it is above the parabola but below the modulus function, which means this region. Here we can use a shortcut method. We know that area of parabolic trough is 2/3 area of the rectangle whose length is 4 and breadth also 4. So length 4 into breadth 4, 32 upon 3. From this we will subtract area of upper triangle, this one, half base into height, half 4 into height 2, 4. So required area of the region 32 upon 3 minus 4, 20 upon 3. Hence the correct answer option is 3, 20 upon 3. In this question, mean is 5.5, so summation xi will be 5.5 multiplied by 10, 55. We write the new mean from the given conditions, summation xi minus the wrong values 4 and 5 plus the correct values 6 and 8 upon 10, that will be 55 minus 9 plus 14 upon 10, 60 upon 10, 6. Now we have variance equals summation xi square minus square of wrong readings 4 square and 5 square plus square of correct values 6 square and 8 square upon 10 minus new mean square, that is 6 square. Summation xi square is given to be 371 minus 16 minus 25 plus 36 plus 64 upon 10 minus 36. This will be 430 upon 10 minus 36, 43 minus 36, 7. So we got the variance 7. Hence the correct answer option is 1, 7. This question is on binomial expansion and we have to find the largest coefficient in the expansion of 1 plus x raised to n plus 4, and it is given that coefficients of 5th, 6th and 7th terms of this binomial expansion are in AP. पहिला प्रथम आपण 1 plus x raised to n plus 4 equals लिहूया 1 plus x raised to capital N म्हणजेच small n plus 4. r plus 1th term binomial expansion मध्ये असते NCR into this x raised to r. त्यामुळं 5th, 6th आणि 7th टर्मचे कोएफिशियंट्स होतील NC4, NC5 and NC6. आता हे कोएफिशियंट्स आहेत AP मध्ये, त्यामुळे आपल्याला लिहिता येईल 2 times NC5 equals NC4 plus NC6. 2 into, आता कॉम्बिनेशन्स लिहूया, n फॅक्टोरियल कॅन्सल होईल. हे एक्सप्रेशन आपण रिराईट करूया 4 फॅक्टोरियल आणि n-6 फॅक्टोरियल कॅन्सल करूया आणि राहील हे पुढं होईल 5 1 जार 5 6 जार 30, n-5 कॅन्सल करूया, क्रॉस मल्टिप्लाय केल्यावर मिळेल आणि शेवटी आपल्याला मिळेल n स्क्वेअर minus 21n plus 98 equals 0. हे क्वाड्रॅटिक इक्वेशन ज्याची रूट्स असतील 7 and 14. आता n म्हणजे n plus 4 आहे, म्हणून n plus 4 7 होईल किंवा n plus 4 14 होईल, म्हणजेच n होईल 3 किंवा n होईल 10. प्रश्नात n is not equal to 10, त्यामुळे हे आपण रिजेक्ट करूया आणि n equals 3. आता 1 plus x to the power 3 plus 4 होईल 7, ज्याच्यामध्ये असतील 8 टर्म्स, त्यामुळे मिडल टर्म्स 2 असतील. लार्जेस्ट कोएफिशियंट हा मिडल टर्मचा असतो. इथं 2 मिडल टर्म्स असतील 7c3 आणि 7c4, जी असेल 24 कॅन्सल होईल आणि आपल्याला मिळेल 35. त्यामुळे करेक्ट आन्सर ऑप्शन असेल 2, 35. In this question we have to find product of all rational roots of this equation. First we will write the equation as it is, which will be, we will put t for this x square minus 9x. This will be which is that is t square plus 21t plus 98 equals 0. After solving this, t is minus 7 and t minus 14. Now we will back substitute and put x square minus 9x equals t, which is 7, and x square minus 9x equals t, which is minus 14. We get two quadratic equations. We will solve them by quadratic formula. X equals minus b 9 plus minus b square minus 4ac 81 minus 28 upon 2a, which is 2, and here x equals minus b 9 plus minus square root b square minus 4ac 81 minus 56 upon 2a, which is 2. 9 plus minus root 53 upon 2 and 9 plus minus 5 upon 2. This gives x equals 7 and x equals 2. We require only rational roots, so we will choose these two roots only and reject these irrational roots. We want product of these rational roots, so the product of roots will be 7 2s are 14. Hence the correct answer option here is 1 14. Traditional method of solving this system of equations is solving these two determinants to get lambda from this determinant and then mu from this determinant and finally get the value of mu minus 2 lambda. But this involves a lot of calculations. Therefore, we will use another method which is quicker. We will multiply this first equation by 50 and then subtract it from this third equation. So the first equation becomes 100x minus 50y plus 50z equals 200. Subtracting, we get 3y plus mu minus 50z equals 12. We will name this 1. Next, we will multiply this second equation by 20 and subtract it from this third equation. So here the second equation becomes 100x plus 20 lambda y plus 60z equals 240. After subtraction, this becomes minus of 47 plus 20 lambda into y minus mu minus 60 times z equals minus 28. Multiplying throughout by minus 1, this will be 47 plus 20 lambda times y minus mu minus 60 times z equals 28. We name this 2. Now these equations have been converted into linear equations in two variables y and z. Now for infinitely many solutions, we have this 3 upon this 47 plus 20 lambda equals this mu minus 50 upon this 60 minus mu equals 12 upon 28, 3 upon 7. By cross multiplication, after solving, we will get lambda equals minus 2. Similarly, second equation, solving which we will get mu equals 53. We have to find the value of mu minus 2 lambda. 53 minus 2 times lambda minus 2 gives the value 57. So the correct answer option here is 4, 57. In this question, it is given that f is a differentiable function and this expression is given and we have to find f of 2. Since f is differentiable function, we will differentiate the given expression, which will be, for the first term, we will use product rule. So first function into derivative of second f dash x plus second function f of x into derivative of first 4 times x plus 2. Next derivative of this minus 6 x plus 2 equals 10 times x plus 2 f of x. We will substitute for fx y so that f dash x will be dy by dx. So the expression becomes into dy by dx plus y times 4 into x plus 2 equals 10 times x plus 2 y. 2 times x plus 2 whole square dy by dx equals 6 times x plus 2 into y plus 6 into x plus 2. This will become, now in order to get f of x and hence f of 2, we have to solve this differential equation. This can be converted into a variable separable form by transposing the terms. So this we write y plus 1 dy equals 3 upon x plus 2 dx. Integrating, we get ln y plus 1 equals 3 ln x plus 2 plus ln constant of integration c. This will be y plus 1 equals c times x plus 2 whole cube, which is the general solution of the differential equation. Now we have to find the value of c. For this, we will put x equals 0 in this original expression. So this will be equals 10 times integral from 0 to 0 t plus 2 f of t dt. Integral from 0 to 0 is 0. So this will be 10 into 0, 0. This will be 8 of f0 equals 12. So f of 0 will be 12 by 8, 3 by 2, which also means 0, 3 upon 2 satisfies this general solution. So 3 upon 2 plus 1 equals c times 0 plus 2 cube, that gives c equals 5 upon 2 upon 8, 5 upon 16. Now is the time to get f of 2 from this general solution. So f of 2, which is y in this case, is minus 1 plus 5 upon 16 into 2 plus 2 whole cube, which will be 20 minus 1, 19. So here we get f of 2 is 19. In this question, sec square of tan inverse alpha plus cosec square of cot inverse beta is 36, and we have to find alpha square plus beta. When alpha is less than or equal to beta, alpha plus beta is given to be 8. We can write sec square of tan inverse alpha as 1 plus tan square of tan inverse alpha, plus we can write cosec square of cot inverse beta as 1 plus cot square of cot inverse beta, which is 36. This will be 1 plus alpha square plus 1 plus beta square equals 36. Alpha square plus beta square will be 34. We are given alpha plus beta equals 8. Beta is 8 minus alpha. So this becomes alpha square plus 8 minus alpha whole square equals 34. Alpha square plus 64 plus alpha square minus 16 alpha minus 34 equals 0. 2 alpha square minus 16 alpha plus 30 equals 0. Alpha square minus 8 alpha plus 15 equals 0. Solving this quadratic equation, we get alpha equals 5 and 3. From this equation, beta will be 3 or 5. We have to take alpha less than or equal to beta. So we will take alpha equals 3 and beta 5. And alpha square plus beta will be 9 plus 5, 14. In this question, we have to find number of 3-digit numbers which are divisible by 2 and 3 but not by 4 and 9. Total 3-digit numbers will be, say n. We have the last 3-digit number 999, first 3-digit number 100 plus n minus 1 into common difference 1. N minus 1 equals 899. So n will be 900. Numbers which are divisible by 2 and 3 are divisible by 2 multiplied by 3, that is 6. So numbers divisible by 6 will be 900 upon 6, 150. Numbers divisible by 4 and 9 are also divisible by 36. So numbers divisible by 36 will be 900 upon 36, 25. So the required number of 3-digit numbers will be those which are divisible by 6, which is 150, minus those divisible by 36, 25. So 125 is the answer. If you like this video, please like, share and subscribe this channel. Thank you.